quiz on this computer. Pretty sure I talked about axioms in the notes. So axioms are like this, the quote unquote self-evident sort of like basic building blocks that we build on. And then from that, we put these axioms together. You kind of have to start somewhere assuming something, right? And so we put those building blocks together, these different axioms, and then those produce the theorems that we have in math. So a lot of the axioms are things that seem like definitions, things of that sort. And I think I talked about what Peano's axioms in the notes. So not not the most interesting stuff to read, but there's reasons why they're doing it. Was it Hilbert was also a big one that tried to axiomatize things. I think Russell was in there with him. Hume, I think, was also another one. There was quite a big overlap between people that were studying like logic and philosophy and math. And if you ever go research like the Vienna circles, it was like a whole circle of them doing those sorts of things. So this guy was Euclid. So we're moving on to geometry. All right, find the perimeter and the area. So I have this one broken up into two different like sort of parts. I didn't know how big is this thing? I think the figures are like plenty big on your phone if you're just looking at it on a phone. Yeah, that's like plenty big to see the numbers. I can see it. Y'all got better eyes than me, probably. So, not even this one. The next one, I think it's even bigger. So what is the perimeter? I think that's the first thing we're going to want to find. Peri meaning around, meter meaning to measure. Oh. And so most of the stuff, like pretty much everything you've ever studied is going to be Euclidean geometry. That's your normal sort of geometry. There are other forms of geometry, and they do have their applications. Where y'all at? Find me that perimeter. What do I got? 8 more people? Come on. I ain't that many numbers to add. We gotta get, oh man. Y'all spending too much time on adding some numbers, I feel like. I got just like beat by the time you get to this class. It's like 3 o'clock in the afternoon. Probably have to wake up, be at school at like 8 or something, probably. Huh? What chat's going on? Where are we at? We got 3 people. Come on. I'm going to hit end on this thing. So what are the 3 numbers you should be adding together? The 3 on the outside, the 5 and the 5 and the 8. The perimeter on this guy is the measurement around the outside. 5 and 5 and 8 should give you 18, I believe, the last time I added those numbers. Woo. All right, so I think a few people are getting it. What'd y'all get wrong? What'd y'all do? You added the 3 maybe? Got 21 in there or something? Are there any 21s? There's the 12s. Yeah, there's a 21. There's a 21. So don't add the 3 that's in the middle. That would be like a height. And so the next thing is, how do I find my area? So what is the formula for area? Someone tell me that. What's my formula for the area of a triangle? Oh, I see what you're doing. think some of y'all might have been, never mind, I don't want to say it. Probably got it wrong anyway. Be my luck. What's the formula? Some of y'all are getting things. What's the formula for finding the area of a triangle? Y'all are getting it. Some of y'all are getting it correct. Not all of y'all, but some of y'all. So who knows? Anybody? Someone, y'all are typing it into this thing. That's not what I asked. Someone typed it in there. So the formula for the area of a triangle. Nobody's going to tell me. Oh, yeah, base times half divided by 2, or half base height. So if you think about a triangle, it's like if you take a rectangle and you do the diagonal. If you have a right triangle, that's one way to get a right triangle. So if you're doing a diagonal, you're taking like half the area of that thing, right? You're slicing that rectangle in half to get a right triangle. If it's not a right triangle, you have to do some shifting around maybe. You have base height this one, you have base height the other one, and you add them together. It's still the same thing. It's half base height. Okay. So I think some people are getting that correct. Some people are giving me the formula for the area. All right, so we have this window that we want to find the frame around it, and we want to find the glass in it. So a picture window has a length of 8 feet and a height of 6 feet, with a semicircular cap at each end. How much metal trim is needed? So they want the metal trim around the outside. They do not want this stuff on the inside. That is not what they're asking for. So how much trim is needed around the outside of the window is going to be the first question. What's the perimeter of a circle called? We don't really call it perimeter. What do we call it?
Circumference?
Yeah, that's it. Circumference. What's the formula for circumference? And if you have to use pi, use 3.14. I think that's what I did. Someone telling me what's the formula for circumference?
Is the formula pi times the diameter?
Yeah, so pi times the diameter, or if you want to throw radius in there, your diameter is the same as twice your radius. So you could say 2 pi r or pi diameter. Either way, that's it. That's it. I have like 3 devices of buttons here. It's like, gotta remember which one I'm putting in where. Oh yeah, 10 people got this. So we're going around the outside of the subject. So really, I hope like this is what you're seeing, right? Like you have this object in here, and we see this span of 8 feet. But if we like take out this span of 8 feet and we put these end caps together, it kind of like just gives us a whole circle. So I hope what you're doing is like taking this 8 feet, and the other thing we got to find is the perimeter or the circumference of the circle. And if you're doing pi, you can use 3.14. Usually, I think I'm sticking to rounding to 2 decimal places for the most part. There's like 8 people still haven't responded to this. Is this like I don't know if it's like if you're really taking that long. Are they really taking that long?
I'm pretty sure I messed up something.
I can't. What is it? Let me like scroll down. 3, 4, 8, 5. Seems like y'all are all around. Probably. Looks like y'all are all over the place.
Right at the end, when I was putting in my answer, I fat fingered the / key, so it's just my answer plus /.
Oh yeah, that's gonna count that wrong, but it'll be all right. Question mark. I don't know what a question mark means. Oh shoot, that doesn't. Oh, sorry. Dang it. It's gonna make you put in an answer again. Hopefully not. Nope. Okay, good. Okay, so I don't know what a question mark means. You're gonna have to ask the question. We are doing the perimeter of this object, so it should be 8 plus 8 plus 6 pi is what you should be doing. If you have questions about that or don't know where I'm getting 6 pi from or why I'm doing it, now's the time to ask. Oh, it just skipped over it. Oh, that's because I got to hit end question, huh? It doesn't like tally up the question until I say end it. Do you want to proceed? Yes. All done. There we go. So there's 5 people that didn't answer that. Where are we on solutions? Someone said 34.85. Oh, shoot. I guess I should probably add to that one, right? What was that, slide 6? Okay. It should be 34.84, 34.85. And then now we want to know how much glass are we going to need for this thing. So that first one was like asking how much trim do we need is like the same thing as asking perimeter. What is this asking for? We want to know how much glass is going to fill this thing. And I think if you round to 2 decimal places where I kept things. And there really should be units on these things, but if you don't put in units, I think it'll still count it correct. I should still count it correct. So what are they asking for? Not all at once. Dude, like, I don't know how to tell y'all this, but you know, class goes as fast or as slow as you let it, man. And if I ask a question,
It's
it's taking
asking
like,
for the area, right?
yeah, that's what it's asking for. But like seriously, man, if I'm asking a question and it's like taking minutes and minutes for you to answer something that should take seconds, like this class is gonna drag on and it's gonna go past where it's supposed to because we have material to cover. Like, I'm not trying to be rude, but like, man, like talk to me a little bit. Like, I don't think I'm asking for like too much. It's just like it makes it really rough. And like it makes it really rough on me and it makes it really rough on you, and I don't understand it. So yep. Yeah, so they want area. So what is the area of a circle? What is the formula for the area of a circle?
Pi times the radius squared.
Yeah, pi r squared, that's it. So we have two sort of different little things we need to figure out in here. We have like this area in here, and then we also have the circle. And maybe something else to note is that they're giving you what 6 foot is like a diameter. So that is not your radius. So be careful there. So I hope the first thing you're doing is finding the area of what this little rectangle, 6 and 8, will give you 48. And then you have to add 48 to whatever the heck the area of that circle is going to be. Got a little rectangle in here, and then if we delete the rectangle, we got a circle left over. Where are we at? 6. Ooh, some of these look high. I don't know where y'all getting these from. Are you multiplying your pi and r before you're squaring it? Is that what you are doing? Or are you doing? Okay. 161 is coming from not dividing the diameter by 2, right? So they are giving us a diameter of 6. We have to divide that by 2 to get 3. And then I think the other thing was coming from probably like squaring it after you multiplied by pi. I don't know what you do. I hope you figure out what you're doing wrong, because y'all aren't asking any questions, any answers, or responded to anything pretty much. Okay, so hope you're figuring it out. That's all I can say. Y'all have to take a test, and you either like,
What was the
Did
answer
this-
to the other one?
huh? Oh, sorry. Woo. Didn't end it, did I? I mean, I know you come from high school, but like entering college, like you will fail in college if you don't do what you're being asked to do. I don't know how to put it nicely, but like you won't pass. In high school, they'll kind of pass you along a lot of stuff. Okay, so anyway, this is what, 76.26. So it should be 48 plus, what is it, 9 pi? If we divide this by 2, it'd be 3. If we square it, it'd be 9. So it should be 48 plus 9 pi. And if you got close, if you're like a decimal place or 2 off, that's fine. If it's like a rounding error, I'm not trying to count it incorrect. Okay, so this is the figure that they're talking about. And they say refer to this figure showing the region to be covered with plywood under a set of stairs. Suppose that the stairs rise at a steeper angle and are 11 feet tall. What is the area of the region to be covered in that case? So what are they saying? They're saying that now it is 11 feet. So what number am I striking out? Striking out
9
9, and I'm going to put in
and 11.
an 11. All right. So the same problem. And ooh, went too quick. Let's do it again. And how do I find the area of this thing? This is a triangle. The formula for the triangle is what? Half base height. If I plug
1/2 times base times height.
yeah. And if I plug that in for this one, as what, 1/2 times what?
66.
Times 11.
Yeah, times 12 times 11, which gives me 66. 66 square feet, 66 feet squared. So this one, I feel like it's pretty straightforward with the other one, right? They're giving you a triangle, asking you to find the area of it. A parking lot is shaped like a parallelogram and bounded on 4 sides. How much asphalt and square yards is needed to pave the parking lot? So how do I find the area of a parallelogram? This is one of those things, is like if they give it to you this way, this is our base, this is our height. What's the formula for a parallelogram?
So you
Somebody remember that?
find the area of the 2 triangles on the sides and then the square in the middle.
That sounds like a lot of work. And it's a lot simpler. So what do we do? You could like draw this line diagonally, right? And then you could take this little piece over here and put it over here. And we could basically, you could use a lot of proofs, but you could basically be getting a like square out of this thing. Or a rectangle, I mean. If we'd like chopped this little piece off and sliced it and put it over here, it would like form a rectangle that is 180 by 150. And if it's the same as a rectangle, then we're doing base and height. So in a rectangle, we get the right angle, but in a parallelogram, we don't. So we have to get this like sort of diagonal thing happening here, this 150. That's not actually on the object, right? If we measure along here, I believe it would be 180 all the way around. So base times height, 180 times 150, I believe is what we're doing. Did I do that as a, yeah, I guess I did that as a slide. Okay. So hopefully it doesn't take you too long. You already know how to do it. That's the parking lot. And I do believe I put commas in there between every 3 decimal spots. So I think it might count off if you don't. So I don't know. All right, so it is 27,000. That's the 150 by the 180. Ooh, reservoir. Okay, so the water reservoir for a city is shaped like a rectangular prism. It is 250 meters by 60 meters by 12 meters. So 250 meters long, 60 meters wide, 12 meters deep. At the end of the day, it is 70% full. So I want you to think about this. I want you to try to work your way through this. Let's see. At the end of the day, it's 70% full. How much water must be added overnight to fill the reservoir? So what are we looking for? What's the first thing you should probably find on here? It may not be.
The
The
shape.
volume of the whole thing.
Yeah, you probably want to find the volume of the whole thing. And if something is 70% full, how much of that are you going to have to fill? How much of it's empty that you have to fill?
30%.
It's 30%. So we want to take a volume. First, we want to find, I hope this is like the thing that's happening in your head, right? First, we want to find the volume of this thing. 250 by 60 by 12. We want to find the volume of that. And then we want to fill 30% of it. So we want to know what 30% of the volume is. So first find the volume and then try to find 30% of. And we hadn't really talked about how to find percentages. Yeah. Okay, Perla said something. She said it privately, so y'all can't read it. But yeah, that's right. So if you're doing 30%, the first thing I think you want to convert 30 to decimal. Of usually means multiply. And did I talk about it? But what should our units be in? So I didn't make you put any units on here if you don't want to. But what should our units be in? If it's in volume, it should be in, cube, close. You said feet cube? Yeah, here we're doing meters cube. So yeah, it should be in cubic is what I was looking for, cubic units. So our volume isn't going to be in cubics. Our areas are going to be in square. Our single dimensions, like our length Our perimeter, which is a length around an object, those things are single meters, right? Yep. And again, don't forget to put your commas for every 3 decimal places, your thousands places, commas. Did I say that in this class where they like, in certain like places, they swap their commas and their decimal places? I don't know if I realize that. I know in France they do. So for like every 3, they'll have a decimal place. And then where the decimal place goes, they'll put a comma.
Yeah, with French money, they put a comma instead of period.
Yeah, I've heard you gotta be careful like where you swap your money sometimes. Not all of those not all those machines are what do you want to say? Do it fairly, I guess. Especially in the tourist traps. They'll mess around with those rates a little bit and not give you as much as you should. We go over converting currency. That's what I was trying to say. We go over converting currency later when we do unit analysis. All right, so doing the volume of this thing is 250 by 60 by 12. And then we want to multiply that by 0.3 or 30%. And I think, ooh, I didn't hit end. I keep forgetting to hit end on the questions. So let's hit it. Hit it. I don't know what y'all are doing today. I feel like y'all are usually more responsive, and today just like, y'all are super quiet and it's scaring me. You started talking up a little bit after I complained. Oh man, thank you. 54, so at least some of you are getting this correctly. Yeah, I got a test coming up next week. So, and I put up a quiz. I put up a quizzes for the quiz. So the quiz 1, that will be due by the test. So I talked a little bit about this, but the first thing we want to do is find the area of the whole figure. So if we do 12 by 250 by 60 is what I'm doing. I'm multiplying those 3 numbers. They should give me 180. And I'm working in cubic meters because I'm doing volumes. I want to find 30%. So the first thing to do, I have to convert that 30% to a decimal. And I multiply that by the 180K. That's going to give me the 54K meters cubed. Are there any questions about this one?
Why is it divided by 0.3 instead of just divided by 3?
This, are you saying the 30%? Is that what you're saying?
Yeah.
So for 30%, are you saying converting the 30% to 0.30?
Oh, I see. Sorry.
All right. Glad I could answer that. I don't know what I did, but there you go. Any other questions? Okay. So yeah, the 30, we're going to divide it by 100 to get 0.30% per 100. And then we're multiplying 0.3 by that other thing. Suppose you build an architectural model of a new concert hall using a scale factor of 30. Okay. And I talked a little bit about this. This is trying to get at dimension analysis. So if we're doing a scale, that means if I measure a length here, if it's like what, 1 on the scale, it's going to be 30 in real life, right? So if I measure 1 inch, it's going to measure 30 inches in the real life. Or if I measure 1 inch, or if I measure 1 foot here, it'll be 30 feet over there. So there's no real units on these like scale factors. You could put like you could put literally any unit on there, right? But that's kind of what it means. It's like 1 to 30. And you can literally fill it in. That's just the ratio of these things. They're similar objects, so they are sort of proportionate. So how will the surface area of the actual concert hall compare to the surface area of the scale model?
What about the 63?
63 is the problem number.
Oh, okay.
Is that what you're asking? And so the response is the surface area will be blank times larger than the surface area of the scale model. And I'll give you a hint, it's not 30. If our length is 1 to 30, and let's say our length is measured in feet, what is our surface area going to be measured in? If lengths are measured in feet, areas are measured in?
Feet squared.
Yeah, feet squared or square feet. So if we're squaring the feet, and this is 1 to 30 feet, what do you think we have to do to this 30? I'm probably giving y'all too much now, huh?
Square it. We have to square it, don't we?
Mm-hmm. Yes. So when you're doing dimensions, if you're going from 1 to 30, and this is like a conversion factor as well, right? So this is a scale factor. You can also do this with conversion factors, right? 3 feet in a yard. If there are 3 feet to 1 yard, there are what, 9 square feet to 1 square yard? There are 27 cubic feet. We got to keep upping it, whatever the dimension is in our units. It is going to be kind of the same. And we will go a little bit more into this and why this is a thing when we get to dimension analysis or to unit analysis. All right. That's 8 people. Tell me you know how to square. If we square 30, what do we get? I'm about to end it. So hopefully you didn't do 2 times 30 or 30 times 2. That is not what squaring does. I think that's the most common mistake is people will like do 2 times something. It's 30 times 30 will give you, what'd y'all do? Did y'all do, are there any 60s in here? Let's look real quick. No one did it. A lot of y'all got 900, so that's pretty good. 2700, you did one more, one more unit than you should have, one more dimension. Aha, I see that. Surface area. Surface area is a 2-dimensional measurement on a 3D object. So I know sometimes that freaks people out. Yes. So it is a 3D object, but the measurement of surface area is a measurement of area. It's a measurement of squares that go on the outside of that object. How can we coat that object? There's no depth to that, right? To that coat. We're just looking at the plane on the outside, like slapping on a paint or something. We don't really care how thick the paint is, so to speak. We care more about it being able to cover an area. Okay, so this I think might be the same thing, the dimension sort of analysis thing happening again, right? So if we up the dimensions and we start with the scale factor. So this is suppose you magically quadrupled in size, that is your height, width, and depth increased by a factor of 4. By what factor has your weight increased? So is weight going to be dependent upon length, area, or volume? That's the first question you're probably going to ask yourself. Am I going 1 dimension, 2 dimensions, or 3 dimensions to get to my weight? Someone said something. I hope you say volume, right? Yeah, that's your mass. Your mass is dependent upon your volume. So what about that? What dimension is that? I know what a lot of y'all are going to say. Yes. volume is in the third dimension. Rate is width. Well, you can still try to figure it out and answer it before we answer it. Make sure you still get it on the right page. Even if you answer it wrong, you can try to redo it, right? I know you can't resubmit it, but you can still try to figure it out. Try to figure it out on your own. Did anybody do 4 times 3? This one did 4 times 4. 4, 16, 17. Oh, no one did that. Okay. I don't see it. Trying to go so fast, I don't see names. Okay. So I think pretty much people that answered are probably going to answer. It should be 4, and I said to the volume, which is the third dimension. So this should be 4 to the third power, which is 4 times 4 times 4. So if you got 16, I think you went to the second dimension, which is 4 times 4. We want to do it one more time. 4 times 16 is going to give me 64. So you want to multiply a 4 3 different times. 4 times 4 times 4. So I think some of you were 1 dimension behind. I think one of you was a dimension ahead. It's showing up now. So I was losing the connection. Okay. Trying to keep up. Why? Stop it. It's revolting. Okay. Consider a person named Sam who is 20% taller than you, but proportioned exactly the same way. That is, Sam looks like a taller version of you. What size is your waist? That is something that I didn't want you to answer. So I said 39.7. That's good and in the middle. And so now we want to know what size is Sam's waist. So assume your waist is 39.7 inches. And we know that Sam is 20% taller and proportioned exactly the same way. So what size is your waist? Something kind of neat on this one. I'm going to go over. Okay, so she's like what? Or Sam is 20% taller than you. What are they asking for? Waist? Is that what they asked? How does that differ? So she's 20% taller. How much wider is she? So I don't know why it's not two people. Should I go? I don't know what to do. That's the third time, I guess. So how much wider is she? Are the people that are active actually getting it? I guess we're probably about to go on because okay. It should be 47.64. So what are y'all doing? 7.94. Yeah, I don't know what you are doing, but I can't teach I'm not here to teach myself. So if y'all don't ask questions, if y'all don't respond to the stuff that I'm asking, then I don't know what to do. Which means you're probably, if you don't understand this, you're probably gonna fail. So I don't know what to do, but like
I understand. It's just I haven't done this sort of math in a while. So I forgot what I needed to do, and then when the answer came up, I was like, God dang it.
Yeah, same. I haven't done geometry in 3 years.
It's been a while, so it sometimes takes a little bit to remember what to do.
I thought it was a trick question.
I mean, that's fine, but like, y'all gotta just tell me something, like when I'm asking questions or like asking about an approach. And it's just like nothing but silence. Like, I don't know how to take that. Like, I can't, like, I can't hold a conversation that's one-sided, you know, like that's what's happening now. And like,
I'm still confused. Was it like vertically waist?
so it was like, this was a single dimension and this was a single dimension, right?
I was just confused because like, is it like the vertical side of his waist? Because if it's just like, because normally when you measure waist, you go around your body, not vertically upwards. And so being taller wouldn't affect your waist size.
But they're saying that she's proportioned in exactly the same way.
Yeah,
So
that's the reason why it would be the same, because you're 20% taller wouldn't affect your waist size.
Yeah, it's just this key word here is that she's proportioned exactly the same way. And so if she's proportioned exactly the same way, if she's 20% taller and the height is 20% more, then the width will also be 20% more.
Okay.
It's like the similar triangles, right? If we like stretch out the width of the triangle, the height is going to increase correspondingly with it, sort of thing. So if we look here, I think this is probably what most of y'all did, right? You took the 20%, you said there's 39.7. And if you got this correct, this is probably what you did. Plus what? We take those two and we add them back together to get, what was it, 47 point, I can't do it in my head. Too many numbers. 47.64, that's it. That's one way to do it. So this is 20% of your waist, and then we're going to add it back to your waist. The other way you can kind of look at it is that we have one of those 39.7s, and we're going to add what, 0.2 more of the 39.7s? Maybe if I put the parentheses around the other number, it might look a little prettier. So if you know you're sort of, this is the opposite of distribution. Remember your distributive property. The other way is factoring. So if we have something in common, we can kind of factor it out. And you might notice that we get like 1 plus 0.2. Or another way you can kind of think about this is that we have 39.7. And if we're going to increase it by 20%, that's kind of like taking what, 120% of 39.7. So there are multiple sort of ways you can solve this one. And hopefully they all make sense with what you're applying it to. And so what's the next one? Squirrels and humans are both mammals that stay warm through metabolism that takes place in their body volume. Mammals must constantly generate internal heat to replace the heat they lose. And what's it saying? Internally to replace the heat that they lose through their surface area of their skin. In general terms, how does the surface area to volume ratio of a squirrel compare to that of a human being? So is it larger, smaller, or do you think about the same? Why do you think it? So a squirrel, or their surface area to volume. Would it be greater than a human or less than a human? And why would you say so?
Wait. So what numbers are we using?
So there are no numbers. It's just sort of like using what you know about squirrels and humans. Which one do you think has a higher surface area to volume ratio?
So do we put like humans? Do we put a number?
So they're not looking for a number. They're saying, do squirrels have a larger or smaller surface area to volume than a human? What would you say? And why would you say that? And there's a sort of way to think about this, so that I think about it maybe. There's something about and pretty much about like all the surface area to volume. There's a way that I kind of sort of think about it. It might be kind of a horrible way, because it's something that a lot of addicts do. But if you think about medicine, right? If you take a pill or swallow a whole pill, that pill is going to be like really time released. It's going to take a long time to dissolve, right? If I take a pill and I start chewing it up or I crush it up, it's going to be very, very instantaneous in acting. So if I get things that are smaller, more crunched up, their surface area to volume ratio would be larger because they have more surface area. Your surface area is the reactivity space, right? And so if we're talking about medicine, that surface area is how much reactivity we're getting. So the smaller thing would have a larger surface area to volume. And then typically that's the way it is. And I guess I'm giving away the solution probably, right? But usually the smaller thing has a larger surface area to volume, if we're talking about the same sort of volume happening. Well, even here, right? So in this one, squirrels are the smaller sort of object. And even like if you think about who's going to freeze to death first, right? That would be another thing that would indicate surface area to volume. Surface area is where your reaction is taking place. It's where you're losing heat the most, right? And so if you think about like who's going to freeze to death first, is it going to be a squirrel or a human? If we go out there, who's going to be an ice pop first? You're going to have a squirrel pop way before you have a human pop. So that means that the squirrel is reacting to the heat or to the cold, to the lack of heat quicker, right? Does that make sense? Like it's not going to get to your core as quick. There's a lot more volume that's not on your surface, so to speak. And so you would have a lot larger surface area to volume for a squirrel. Are y'all answering this or is it just not responding? Are y'all falling asleep? Okay, there are some people that answered. It is larger. It should be larger. I think quizzes fell asleep this time. And I think this is going to be a similar sort of concept, probably. Same thing, we're talking about squirrels again. Which animal must maintain a higher rate of metabolism to replace the heat lost through the skin, squirrels or humans? Based on your answer, which would you expect to eat more food in proportion to its body weight? Explain. Mus in squirrel. Oh, that's a fair enough timer. What? What are y'all saying? Humans? So if you have, if you're losing more heat and losing more energy, if you have a higher surface area, why are y'all saying humans? I don't understand humans. Someone talk to me. Why are y'all saying humans?
So it's just asking who should have a higher metabolism, humans or squirrels?
Yeah, so who should have a higher metabolism? Who's going to eat more food? They're kind of saying the same thing, right? If you have a higher metabolism, that means you're losing more energy. So who's going to lose more energy to the environment around them? We have to generate heat to maintain our body temperature, right? That's part of living. Who's going to work harder to maintain that heat? A human or a squirrel? If you've ever had like, I had rats for a while. And squirrels are just basically rats with a good PR. So if you've ever had squirrels, I want to end this. This is done. If you ever had squirrels, right? Or you've ever had rats. If you ever had a chihuahua, anything smaller than you, it's always like shivering, right? It's got to stay like kind of in motion just to keep warm. Like they have a really high metabolism. Things that are small tend to have really high metabolisms. They tend to lose energy really quick. They have to maintain it somehow. I think it's typically why they live shorter too. I think higher metabolism animals typically live shorter. I think turtles have a really slow metabolism, right? Slow things down. The other thing, I said squirrels all the way down. That comes from turtles all the way down. Do y'all know about turtles all the way down? About the creation myths? About how there's a world on the back of a turtle, and then there's probably a turtle on that turtle, and then there's a turtle on that turtle. Turtles all the way down. That's where that comes from. Turtles walk so slow, like they start growing stuff on their back. But we want to find this figure. This is my figure. Look at that. I can zoom in on it. Figure that out. So we want to figure out how much we need to seed in this back lawn. So we don't want to put seed on our patio or in our flower garden. We want to seed this thing with some grass seed is what the problem is asking. So what do we want to figure out about this thing? If we're trying to figure out how much seed to put, that's like asking for the what? Area. There we go. Someone said it. So that's like asking for the area. So we want to take the area of the whole thing, but not those parts. So we got to subtract those areas. So this one should be hopefully kind of easy to find. This one, if you got to use pi, use 3.14. It's good enough. And something else. You might also want to realize this is only half of the circle. Are y'all answering? Are we getting it? Is anyone getting it? There's some people. Okay. I hope you can do the area of a rectangle. I hope you can do the area of a square. Area of a circle, we talked about that thing already. It's what, pi r squared? I think I might broke this one down on the next slide. You're still working on it? Do you need more time for this one?
I think we're good.
I'm not sure about the other people, but I'm done.
Okay. Well, yeah, I mean, I don't know. If you're still working on it and I'm not being like, I'm rushing you, let me know. But if you're not going to answer it, then I don't see like any sense in waiting around because you're just holding up the class. Then Okay. So what do the responses look like? Where we got 144.75. Did you get 144.75? Hopefully. A few people did. And we should be in what, feet squared? Something along those lines. If you're 0.02 off, I would count it right. I know that this thing is not like, because it's a machine and I'm not paying it money, so it's going to pretend like it doesn't know how to. Okay, so a little bit about how to do this. I hope the first thing you did was find the area of the full thing. Find the area of the full thing, we subtract the two smaller areas within it that we're not going to seed. So I think the first thing, the easy thing to figure out is the 4x4 should give you 16. The other thing, we have to do pi r squared for this thing. So if we do pi r squared, my r is 5. So if I square that, it's going to give me 25 pi. But then the thing I also have to remember is that it's only a half. So I have to do pi. This is my r squared. And I also have to remember to either divide by 2 or multiply by a half. It's the same thing, whether you divide by 2 or multiply by a half. But I'm getting something like 39.25 for this area in here. And so I do the 200, I take away this, and I take away this. So some people took away, like subtracted this and subtracted this. Some people added these two, and then they subtracted it from the whole thing. Either way, yeah, I think it's the same way, right? It's the same thing. We're taking that 200, we're taking away 16, we're taking away 39.25. And if we do that, we should get somewhere around 144.75. And since we're in area, we're talking about square meters. $144.73 is okay. Yeah, it's fine. That's probably from using like pi differently or using the whole pi. It could be within a cent or two. Within a few cents is fine. Okay, so we have a few more examples I want to go over. I believe it's two more, right? We are on the human lung. What was that? 75. I believe we're on the last two, right? 85 and 87. This is 84. Yeah, that's where we're at. This is 85 and 87. There are two more. And if I'm being honest, I don't feel like these like two problems are necessarily like maybe like what I want to say the best problem for this class. They are a little bit out there, if I'm being honest. The human lung has approximately 300 million nearly spherical air sacs, alveoles. It sounds like some Chef Boyardee or something. Each with a diameter of about 1/3 millimeter. The key feature of the air sacs is that the surface area, because of their surface gas, is on their surface gas is exchanged. I read that really weird. The key feature of the air sacs is their surface area, because on their surface, gas is exchanged between the bloodstream and the air. So what we're saying is we have these lung sacs, or these spherical sacs in your lungs. They're called alveoles. And the key feature to them basically is that they're going to be really small little air sacs. They're like 1/3 of a millimeter in diameter. And so we're going to kind of compare like the air sac having a bunch of these small little tiny 300 million little air sacs versus having like one big air sac. And why is our air sac built as a bunch of little air sacs instead of one big air sac? So the first question they ask is, what is the total surface area of the air sacs? What is the total volume of the air sacs? So in order to get this, we have to know the surface area of a sphere. So that is not something I would expect you to know off the top of your head. Definitely give you a formula for that thing. I don't even know it off the top of my head, if I'm being honest. 4 pi r squared. So our r here, what is my radius here? And this is where you have to be careful. If your diameter is 1/3, what is your radius going to be?
Should be 1/6, right?
Should be 1/6. And how are you getting that? You're taking a third and you're halving it or dividing it by 2. If we take a third and divide it by 2, we get 1/6. So my diameter is a third and my radius would be 1/6. So if I fill in my radius to my surface area, I'm getting this thing. Just filling it into this formula. This is 1 sac. They want to know the surface area of all of these. So now this is a thing where I have to multiply by 300 million. So I have 300 million of these sacs. So I have to put 6 more zeros here, multiply by it, and it gives me a number by like 1.05 times 10 to the 8th. So that means move that 10 decimal places, or 8 decimal places, sorry. This is the surface area of all those little spheres. All the 300 million of them, this is going to be their surface area. That is half of this question. The other half is to find volume. So we're going to do exactly the same thing with volume. We're going to look up the formula for the volume. We know our radius is 1/6. I believe that's this next part here is, what is the volume? This is my formula for volume. Not expecting you to know this off the top of your head. Definitely something I have to look up. So 4/3 pi r cubed. And I know I'm going over these a little quick, but it may not be a bad idea to do like a sort of calculator check and see if you can do these on some sort of technology, some sort of device, right? Make sure you're getting the same number. Make sure you can do cubes correctly, things that like along those lines, right? Are good things to sort of check out. Make sure that you can crunch these things correctly. So 4/3 times 3.14 for my pi times 1/6 to the third is giving me a number somewhere around here, 0.1938, somewhere around there. That's 1 air sac. So guess what I got to do? I got to multiply that thing by 300 million to get all of the air sacs. All right, so part B. Part A, I feel like is a little bit straightforward. It's like, hey, here's the information, plug it into the formula. Part B is where things start getting a little bit more tricky. Suppose a single sphere were made that had the same volume as a total sphere. What would the radius and surface area of such a sphere? How would the surface area compare to that of the air sacs? So the first thing, we want to suppose a single sphere has the same volume as the total volume of the air sacs. So going back, I think I did this in parts. This is my volume of a sphere. We know previously from what we did, if we had 300 million sacs, like what their volume would be. So from part A, that volume that we found is the volume we want to plug in here. And now we want to figure out, if we had one sphere, what would the radius be? Is what we are figuring out now. So now we are solving this thing for radius. So I want to get r by itself. I'm solving for radius. I want to get r cubed by itself, probably. And so if I'm looking there, what is attached to this r cubed down there? What's written in front of the r cube? Oh, you're gonna try to type that in. There's a 4/3 and there is a pi. So we have to take this 4/3 pi and move it to the other side. So what is connecting this 4/3 pi and the r cube? The operation is multiplication here. So if we want to move it to the other side, what is the operation that we use to undo that? And I think I did this piece by piece. So I think
Divide.
gotta divide it. So we're dividing by 4/3 pi. And at this point, I think I just started plugging things into a calculator, if I'm being honest, and try to get this thing. This is just a number over here. So we could simplify this, I believe, into a number. So if we take 5.8 times 10 to the 6 and we divide by 4/3 pi, there's ways you could probably do this by hand and simplify it, but we're just going to use a calculator at this point. Because now we have r cubed equals this number. How do we get r by itself? That's the next thing. And this is really like, this is the kind of step that I think might be going a little bit, maybe it's pushing the edge or the boundary on this class, if I'm being honest. If we have like r squared equals 16, how would we get r by itself? Cubic root? Someone said that. Yeah, that's right. So if this was a square, we would do a square root of both sides. If this is a cube, we want to do a cubic root. So what does that look like? It looks like I've got that radical, but it's got like the little 3 out in front. We want 3 different things that multiply to this thing instead of 2. So cube root is an operation we can do. It will get this down to r. And if we do that, this is something you're going to have to plug in a calculator at this point. So you might have to find a calculator with a cube root button. You might have to figure out how to do the cube root on your calculator. Might have to go to Google and ask them. I don't know. You can usually find someone that has your calculator and can tell you how to do it if you don't know how to do it. Through the wonders of Google and the internet. But this is going to be somewhere around 11.46 millimeters. If I round this, this is 112 millimeters. And this, remember, is what we're talking about, is the radius of a big sphere. What else do we got to do? There's more. What is the surface area? I believe was the next question. So we found our big sphere that has the same volume. We want to know what its surface area is going to be. So we found that thing in the previous part, and now we're plugging it into this, into r squared. So we're plugging 112 into r squared to figure out what our surface area is going to be. And here we go, the surface area of a big sphere. Okay. So now we get this number for the surface area. And then they want us to compare the surface area of the big sphere to the surface area of the little sphere. So these are the things we found. I believe this one was in Part A, this was the one that we just found from part B. And we want to compare these two. We want to see how many times larger this thing is than this. So that means we're going to be multiplying this by some number to get to here. So if we want to figure out how many times larger, we would have to divide these two things. So it is about 670 times greater. I think this is what the book, a lot of these rounding things is what the book gives you, but these middle sort of solutions, I think I did. So that's about 670 times greater if it has the same volume. And then if a single sphere has the same surface area as the total surface area of the air sacs, so now we're going to compare it if it has the same surface area. So we're going to do something very similar. We're going to start out with surface area. We know the surface area from part A of all our little spheres, and that was like 1.05 times 10 to the 8th. And that's what we found way back in part A. So all those little spheres, when we add them up, that's the surface area of them. So now if we have one big sphere that has the same surface area, so part B was one with the same volume, now we're going to find one with the same surface area. What would its radius be? And then based on that, what can you say about the design of the human lung? So from this, we want to solve for R. So I think this one might be a little bit even easier to solve for R. We want to get R by itself. It is being multiplied by 4 pi. So to move that 4 pi to the other side, I'm going to divide by 4 pi on both sides. Now I have an R squared, and I talked a little bit about this. This is like when we have R cubed is equal to a number. Now we have a square. Instead of taking a cube root, we're going to take a square root, huh? And then we'll get that number. And so this is the radius of our sphere if it had the same surface area. So the radius would be ginormous, I think is what they're trying to get at. And so what does this say? Converted that to meters because it was in millimeters, but you would have like a 3 meter long sphere in your in your body, right? Is what this was saying if they had the same surface area. So for the relatively small volume, the small air sacs have a really, really large surface area. So they have a large surface area to volume ratio. And like this is going back to the human and the squirrel, right? The whole big pill versus like crushing it up. There's actually an application for that too, right? If someone's having a heart attack, you crush up the Advil to give to them because it goes a lot faster. So there are actually legitimate applications that aren't just addicts abusing pills, right? But that's also a problem. So they also figure out ways that you can't crunch up pills. It's also another sort of technology that's developed. So the English channel or the channel. This question, I feel like it's semi-fair. It's just really, really worded really horribly. If you don't know what they're talking about, it could be confusing. But they give us all the sort of information, and they tell us about the channel. It runs 50.5 kilometers from Dover to France. The channel actually consists of 3 individual adjacent tunnels, and they're each shaped like a half cylinder with a radius of 4 meters, the height of a tunnel. And how much earth or volume would you have to remove? So first thing is you're probably going to want to know the volume formula for a cylinder. So there is my volume formula for a cylinder. The other thing that they do here is they give you the height is in 4 meters, but they give you what kilometers in this distance. So you might want to convert kilometers to meters. So there are 1,000 meters in 1 kilometer. So multiply it by what, 1,000 to get the number of meters. And then I know we're going over a little bit. Yeah, okay. Someone just said that. Yeah, we're going over a little bit, but we're almost done. We're on the last problem. So we're just plugging stuff in. So V equals pi is 3.14. My R is this 4 meters. My height is this 50. Wait, other way around. Sorry. Did I say that right? Yeah. No, that's right. My radius is the 4 meters. My height is this 5450. And if I plug that in, this is what I'm getting. This is in meters. And so this would be one of those tunnels. This would be a whole cylinder. There are two little things I have to do. There are 3 tunnels, so I have to multiply that number by 3. And then each of those tunnels is not a whole cylinder. It's only a half cylinder. So then you have to divide by 2. So you have to multiply by 3, divide by 2 to talk about 3 different half tunnels that they have there. Or you can multiply by 3 halves in one step. But you should be getting something around like 3.8 times 10 to the 6 cubic meters of earth that they had to remove for the channel. Okay, so that is it. That's all I got for you today. Go out there, do the test review. There is a practice test that you need to do if you haven't done it already. I think most of you have not done it, if I'm being honest. But there is a practice test that hopefully you try before the test. There is a quiz out there that you should get completed and turned in before the test. I know we still have one more section to go over, so technically there might be like 1 or 2 problems on that quiz that you can't do yet. You might be able to do them. Depends. Okay.
Okay, so the test is due on February 15th, right?
Okay, so today we're doing 10A. Yeah, the 15th, you'll come in and take it during class hours, basically. So either go and you'll take it through the lockdown browser. So if you have the, Respondus lockdown browser and monitoring system, so you have to download that separate little browser and log into Blackboard through that browser and take the test through that browser with an active camera. And if there's any problems with doing that and anything pops up that you can't get that done, I will be in Zoom during class hours during test. You can always come by and we can always try to work things out in Zoom somehow. So we can find ways around it if you can't get in through the lockdown browser is what I'm trying to say. Don't just like, oh, I can't get in, I didn't take the test. Like, okay, then you're gonna get a 0. Like you have to like talk to me about like things. Like you can't just like not take things and then expect grades.
So the quiz is due at the beginning of that class.
Just yeah, basically before the test, I think is when I put it. I think maybe like an hour before the test or something. As long as you get it turned in before the test is what I'm looking for. I'm looking for you to have it completed and done before the test.
Okay, perfect. Thank you.
And there's a quizzes that goes along with the quiz. So if you're stuck on something, I'm hoping that will like kind of poke you and prod you along. Yeah, I mean, I'll try to say it. How can I say it nicely? There's a lot of stuff in this class. You can just like quickly scribble stuff on and like kind of get credit for it. If I'm being honest, right? Doesn't mean you're going to learn it, and you're not going to do well on the test. And the test is where you're going to make or break yourself in the class, right? For most classes in college, like the tests are usually where the weight is. So you can do things really, really shittily, I guess is what I'm trying to say. But it's not to your favor. You're not gonna do well on the test, right? You can skimp on your daily assignments, but then it's gonna really bite you in the end. So I don't advise it. Stay on top of your stuff. Any questions? I'm gonna stop recording.